So here we just have a second example of burning of fuel in air. This time we're burning methane. So our first order of business is to balance this stoichiometric equation. So we've got to write the mini equations for each of our elements. So for carbon, we've got A on the left and C on the right. For hydrogen, we've got 4A on the left and 2D on the right. For the oxygen, we just have the 2 times B, so we have the 2 inside the parentheses, the B on the outside, so we have 2B. On the right-hand side, oxygen pops up twice, because now we're not just forming water, but we're also forming carbon dioxide. So we've got 2C plus D. And then finally, we've got the nitrogen equation. So that's going to be the same thing as what we did with the oxygen. So 3.76 times B, which is going to equal E on the other side. So once more equations than we have variables, or more variables than we have equations. So I'll just start off with A equaling 1, which makes C equal 1. So then if 4 times 1 equals 2 times D, that would make D equal to 2. And then if we jump down to the bottom equation, that would mean 2B equals 2 times C, so 2 times 1 plus D, which we just said was 2. So we've got 4 on this side, 2B equals 4, so B equals 2. So we lucked out and got all integer values there. And then of course we don't care that E, the coefficient in front of the nitrogen on this far side, is going to equal a decimal since it's just a pass-through. But we've got 3.76 times B, where B is 2, so we're going to end up with 7.52 as our coefficient there. So then our resulting stoichiometric equation, we've got 1 mole of the methane plus B is 2, but remember that's not 2 moles of air, but 2 times the 4.76 that we have on the inside. And then C is 1, so it produces 1 mole of carbon dioxide. D is 2 moles of water. And then for the E, it's the 7.52 moles of the nitrogen gas. So for our air to fuel ratio, the molar ratio, we're going to take that number of moles of air. So again, that's 2 times 4.76. So that multiplies out to make 9.52 moles of air for every, and then we've got 1 mole of the methane, the CH4. So 9.52 is our ratio. And then we can take that 9.52 moles of air per mole of methane, and now we need to convert that to masses for the mass ratio. So for 1 mole of the methane, so we've got the 1 carbon atom plus the 4 hydrogen atoms, so that's going to give us 16 grams of the CH4. And then we're going to use that same effective molar mass of air. So for 1 mole of air, we've got 28.8 grams of air. And so if we multiply everything out, divide by 16, we end up with a final result of 17.1 grams of air per gram of the methane.